Hi, I'm Janice Farnholz-Province, and we're going to go over a few IV drip calculations. So grab your calculator and have it ready, and we'll get started. We're going to go over the calculations both forward and backward, so you can double check your work. Here's a list of the types of calculations we'll go over. If you have your drip card handy, I think that will help as well. So I'll go over how to use this, doing both the forward and the backward calculations. All right, so what's this constant thing, or this magic number as some people like to call it? Well, it's a totally awesome thing that helps simplify your calculations, and it eases your calculations when you're having to do frequent titrations of drip and then document those. So it's just a quick boom, boom, boom. So it's as easy to calculate as 1, 2, 3. So first you have to know what the concentration of the drip is. For example, if we have nitroglycerin, it's 50 milligrams in 250 mLs. So we're going to divide 50 into 250. And then the second step is knowing how the drug is dosed. Is it mics per kilo per minute? Is it mics per minute? And then for the example of nitroglycerin, where it's milligrams, we need to convert it to micrograms because it's dosed in mics per kilo per minute. So we're going to multiply times 1,000. So anytime you see that it's dosed in micrograms, you need to convert it if it's not already in micrograms when you put it into the bottle or when it comes in the bottle. And then lastly, we're going to divide by 60 if the drug is given in minutes. For example, mics per kilo per minute or mics per minute. We're going to divide by 60. So with the example of nitroglycerin, if you just plug it all into your calculator at one time, you'll come up with the constant of 3.3. So go ahead and do that. 50 divided by 250 times 1,000, because we're converting it to micrograms, divided by 60, and you get 3.3. All right, let's do a little example of how to use the constant, or how you're going to love using the constant after all of this. All right, so it's shift change, and you have a new patient on a nitroglycerin drip, and the pump is set at 14 mLs per hour. So the long way to figure out the dose would be to take what is in the bottle, so 50 milligrams divided by 250 times 1,000 divided by 60 minutes because it's delivered in mics per minute, and then we're going to multiply times the number that's set on the pump, 14. So what do you get when you put that in? That's right, 46 mics per minute. All right, and then the short way to do it is to take that constant that we already got. Remember, to get the constant, you did 50 divided by 250 times 1,000 divided by 60 minutes, and that gave you 3.3. So now you're going to take the constant. You've just shortcut all of that math. 3.3 times 14 mLs per hour, that's what's set on the pump, and you get what? 46 mics per minute. Good. All right, let's practice. So figuring out the constant, how are we going to do that? Our first example there is dopamine. So here is the back of the drip card that shows you the backward calculation. So in number 1, you see you have the milligrams over the mLs or cc's. And then if the drug is dosed in mics per minute, then you're going to multiply times 1,000 milligrams because that's equivalent to 1 milligram. And then you're going to divide by 60, which is equivalent to 1 hour. And then you get your constant. So let's do a couple practices. So dopamine is 400 milligrams in 250 mLs. We know that it's dosed in mics per kilo per minute. So let's do that math. So 400 divided by 250 times 1,000, because you need to change it to mics, and then divided by 60, and what do you get? 26.7. Good job. All right, for Levofed, it's 4 milligrams in 250 mLs. It's dosed in mics per minute. Let's do that math. So you put that in there, 4 divided by 250 times 1,000, because it's dosed in mics, divided by 60, because it's dosed per minute, and what do you get? 0.27. Good job. All right, and then let's do nipride. Nipride, it is a concentration of 100 milligrams in 250 mLs. It's dosed in mics per kilo per minute. So we're going to take 100 divided by 250 times 1,000 because it's dosed in mics, divided by 60 because it's dosed in minutes. And what do you get? 6.7. Good job. All right, one more. Amiodarone. Amiodarone is in 900 milligrams in a 500 ml bottle, and it's dosed in milligrams per minute. Aha, we've been doing mics, so don't be fooled. If you look up at your drip card now, the middle part on number 1, it says milligrams per cc or ml, so we've got that. We're going to do 900 divided by 500. And then do we need to do the 1,000 mics, convert the milligrams to mics? Well, if we look back under the amiodarone, no, because it's dosed in milligrams per minute. So we're going to do 900 divided by 500, so we're going to skip that middle step. And then we see that it is dosed per minute, so yes, we're going to divide by 60. So 900 divided by 500 divided by 60, we get 0.03. All right, let's do a few more. So we have diltiazem. You see over on the left that diltiazem is dosed in milligrams per hour. Okay, so looking up top at our backwards calculation, when you do the milligrams per mLs or cc's, we have that. The concentration is 125 in 100. And then the next step is to multiply times 1,000 in order to convert it to mics. Well, is that going to be the case with diltiazem? No, because you see that it's dosed in milligrams per hour. And then if we move over to the next step to get the constant, we usually divide by 60. So again, if you look back under diltiazem, how is it dosed? Milligrams per hour. So do we need to divide by 60? No. So what is your constant for diltiazem? It's going to be 125 divided by 100, and that gives you 1.25. All right, let's do propofol. So propofol is dosed mics per kilo per minute. Propofol comes in a glass bottle already mixed for you, and it is 1,000 milligrams in 100 mLs. Do we need to multiply it times 1,000? Yes, because it's mics per kilo per minute. Do we need to divide by 60? Yes, because it's mics per kilo per minute. So when you do the math, put it in your calculator all at one time. 1,000 divided by 100 times 1,000 divided by 60, and we get 167. Good job. One more. Esmolol, a mics per kilo per minute. So this one is a little tricky. 2.5 grams divided by 250 mL. So the esmolol comes in grams. All right, how many milligrams is 2.5? So that's going to be 2,500 milligrams divided by 250. Do we need to multiply times 1,000? Yes, because it's mics per kilo per minute. Do we need to divide by 60? Yes, because it's mics per kilo per minute. So the math is going to be 2,500 divided by 250 times 1,000 divided by 60, and we get 167. All right, now let's do heparin. We didn't say we were going to talk about this, but it's something that we do give. So how is heparin dosed? It's dosed units per hour. So looking back up top to our backwards calculation formula here, do we have milligrams per cc? No, we have units per cc or units per ml. Do we need to multiply times 1,000? No. Do we need to divide by 60? Well, again, it's units per hour, so no, we don't need to convert it to minutes. We're going to leave it at that. So just like we did with the diltiazem, with the heparin, we're going to do 20,000 units divided by 500. And what do we get? Our constant for heparin is 40. All right, with propofol, I just wanted to show you a picture of this. We're used to the little vials over on the left-hand side if we're doing any procedures. But on the right-hand side, you'll see that the Propofol or Diprivan is in a big glass bottle. You don't want to mix Propofol. It comes this way. Don't dilute it. All right, backwards calculations. let's do some more practice. So here's your constant times your drip rate divided by kilograms equals your mics per kilo per minute. So we've figured out our constant now, and now let's put it into use. So here's an example. We have dopamine. The dopamine is infusing. It's at 42 mLs per hour on the pump, and the patient weighs 70 kilos. We know that the concentration of dopamine is 400 milligrams and 250 mLs. So what was our constant for dopamine? I'll let you figure it out for a second. Remember, it was 400 divided by 250 times 1,000 divided by 60, and you get 26.7. So you're going to take your constant, 26.7, multiply it by 42, which is set, the pump is, that's what it's set at, and then you're going to divide by the patient's weight of 70 kilograms. So what do you get? Put it in your calculator all in one shot, 26.7 times 42 divided by 70, and you get 16 mics per kilo per minute. So that's what you would document in your chart, that the patient is on dopamine at 16 mics per kilo per minute, which is equivalent to 42 mLs per hour. All right, let's do an example with nipride. Nipride is dosed how? It's mics per kilo per minute as well. So we have the nipride set at 12.5 mLs per hour on the pump for a 70 kilo patient. The nipride concentration this time is 100 and 250. So figuring out the constant for nipride, we're going to do 100 divided by 250 times 1,000 divided by 60, and we get a constant of 6.7. We're going to take that constant, 6.7, or if you looked at the back of your drip card, you would get it. 6.7 times what the pump set at, 10.5 mLs per hour, divided by the patient's weight of 70, and we get 1 mic per kilo per minute. All right, so now let's do nitroglycerin, not to be confused with nipride or nitroprusside. So we have nitroglycerin, which is 50 milligrams and 250 mLs, and we have the pump set at 10.5 mLs per hour. So we're going to take our constant of 3.3. Remember, we got that by dividing 50 into 250 times 1,000 divided by 60. We got 3.3. So our constant of 3.3 times what the pump is set at, 10.5 mLs per hour, and we get 34.7 mics per minute, or round up to 35. All right, so now you've initiated the drip, and what's the, you have to put in the number now on the pump. Now what do? So what's your starting dose? What's the order? For example, if you have an order to start dopamine at 5 mics per kilo per minute, what is your patient's approximate weight? Because if it's dosed in kilos, you need to know that. And what is the concentration of the drip in micrograms per ml? So you're going to figure out what the denominator is, that's the bottom number when you're doing division, to use your next step. So for example, we have dopamine, 400 milligrams and 250 mLs. Is it dosed in mics per kilo per minute? Yes. So we're going to multiply times 1,000, and then we're going to get the denominator, that's the bottom number, what's in the bag, how much drug is in the bag, and that's going to be 1,600 mics per ml. So every single ml that comes out of that dopamine bag has 1,600 mics in it. Okay, so you have your order for dopamine to start it at 5 mics per kilo per minute on your 70 kilo patient. So if you look up top, we've got an example there. You're going to take whatever's ordered, that's the mics per kilo per minute, multiply it times the kilograms if it's a weight-based drug, and multiply it times 60 if you're dosing it in per minute. And then you're going to divide by whatever's in the bag, so mics per ml. So let's do an example. So we're going to multiply the amount ordered, 5 mics per kilo per minute, times the patient's weight of 70, times the minutes of 60. So 5 times 70 times 60, and then we're going to divide by the denominator. And we already figured that out, right? So we took 400 divided by 250 and multiplied times 1,000, and we got 1,600 mics per ml for the dopamine. So let's do that math. Just put it all in your calculator all at once. 5 times 70 times 60 divided by what's in the bag of 1600 mics per ml, and you get 13.1 mLs per hour. So that's what you're going to set your pump at, or 13. All right, good. And here's a little picture of dopamine. So be careful about infusing anything that constricts the blood vessels, like epi or dopamine or levofed, into a peripheral line. A central line is preferred. Okay, let's do another example of a forward calculation. So we have nitroglycerin that we need to start at 10 mics per minute. So let's figure out what the denominator is first. So how many mics per ml are in the bag? So we're going to take 50 divided by 250 and multiply times 1,000, and we get what? How much drug is in the bag? 200 mics per ml. Good. And then we're going to take the 10 mics per minute, that's the order, multiply it times 60. We're not multiplying times any weight because it's not a weight-based drug. And then we're going to divide it by the 200 mics per ml, or the denominator there. And we get 3 mLs per hour. Okay, one more example. We have an example to start nitroprusside at 0.3 mics per kilo per minute on an 80 kilo patient. So we want to know what our denominator is going to be. So to figure that out, we have 100 mLs in a 250 ml bottle, 100 milligrams in a 250 ml bottle. We know that it's dosed in mics per kilo per minute. So we're going to do the math of 100 divided by 250, multiply times 1,000, and we get 400 mics per ml in that bag. And then we're going to take the order. So 0.3 mics per kilo per minute, multiply it times the patient's weight of 80, multiply times 60, because this is dosed in minutes, and then we're going to divide by the denominator of 400 mics per ml. So when you plug that math in, 0.3 times 80 times 60 divided by 400, you should get 3.6 mLs per hour. That's what you're going to set your pump at. All right, now we have an order for dopamine on a 90 kilo patient. We want to start at 5 mics per kilo per minute to titrate to a blood pressure of over 90. So what's our bag? Take your 400, divide it, what's in the bag? 400 divided by 250 times 1,000, and you get 1,600 mics per ml in the bag. And then we're going to take the order and we're going to divide it by what's in the bag. So 5 times 90 times 60 divided by 1,600, and we get 16.9 mLs per hour, or 17. All right, and then after 10 minutes, blood pressure remains less than 90. So your preceptor increases the rate to 33.8 mLs per hour. You need to document this change. What are you going to write? So now you get to use your constant. What is your constant for dopamine? 26.7. So all you have to do is do the math. 26.7 times what the pump is set at, which is 33.8, and then divide it by your patient's weight of 90 kilos, and you get 10 mics per kilo per minute. And then you're going to document your action. So dopamine increased to 10 mics per kilo per minute, which is equivalent to 33.8 mLs per hour. And that was our goal because we want to increase the patient's blood pressure to 90. All right, here's another example. Nitroglycerin drip at 10 mics per minute. Titrate to relieve chest pain. So what's in the bag? 50 divided by 250 times 1,000 is 200 mics per ml. And then we're going to do the order. So the math is 10 mics per minute times 60 divided by 200, and we get 3 mLs per hour. So that's what we're setting the pump at. All right, after your bathroom break, you come in and find the nitroglycerin pump rate is now at 12 mLs per hour. Document the change. So we're going to take the constant of 3.3. We're going to multiply it times 12. That's what the pump's set at. And we get 39.6 mics per minute. All right, so document your actions. Nitroglycerin increased to 39.6 mics per minute. That's equivalent to 12 mLs per hour for complaints of 4 out of 10 chest pain. All right, here is your patient. Yikes, right? That's a lot of drips. Okay, so what is the dose of the Levofed that this patient's getting? And what it says on the pump is 94 mLs per hour. Okay, so first you want to know how Levofed is mixed. What's the concentration? What's it dosed in? So we're going to do 4 milligrams divided by 250. And when you do that math, 4 divided by 250, you get 25 mics per minute. Good. All right, next question. What dose of Versed is this patient getting? So on the pump there it says 1 ml per hour. So how is Versed mixed? It is mixed 100 in 100, 100 milligrams in 100. So how much drug is this patient getting? 1 milligram per hour. All right, here's another patient. So what is the dose of the heparin that this patient is getting? So the pump says that it's set at 31 mLs per hour. The heparin is mixed, and you should remember this from earlier, 20,000 units in 500 mL. So what's the constant for that? It's 20,000 divided by 500, and that gives us 40, right? So using the backwards calculation here, we're going to multiply the drip rate, or the constant, 40, times what's the pump is set at 31, so 40 times 31, and that gives us 1,240 units per hour, not minute, but hour, right? Okay, one more example here. What is the dose of the fentanyl that this patient is getting? So fentanyl, the pump is set at 5 mLs per hour, and fentanyl comes in 2,500 mics in a 250 ml bottle or bag. And so doing that math, 2,500 divided by 250, we get 10. That's our constant, times our drip rate, so 10 times 5 is 50 mics per hour. A few more examples here. This patient's on a Versed drip, and the pump says that it's set at 1 ml per hour. So Versed is mixed 100 milligrams in 100 mL, so that gives us a constant of what? It's pretty easy, 1. So 1 times 1 is 1 milligram per hour. All right, what about our fentanyl? The fentanyl is set at 5 mLs per hour. How is fentanyl mixed? It's mixed 2,500 mics in 250 mLs. So what did we get when we did 2,500 divided by 250? We got a constant of 10. So 10 times the 5 mLs per hour, that gives us 50 mics per hour. Okay, one more example. Here's your patient on a Levofed drip, and the pump is set at 28 mLs per hour, and Levofed is mixed 4 milligrams in 250. So we've got to do some math in order to figure out what our constant is. So let's do 4 divided by 250, and are we going to multiply times 1,000? Yes, because it is dosed in micrograms per minute, and then we're also going to divide by 60 because it's dosed in micrograms per minute, and you get 0.26667 or 0.27. So if you multiply 0.27 times what's set on the pump, which is 28, you're going to get 7.6 mics per minute. Good job. All right, last one. What dose of neosynephrine is this patient receiving? So neosynephrine is dosed in mics per minute, and it's mixed 60 milligrams in 250 mLs. So doing the math here, 60 divided by 250, do we multiply times 1,000? Yes. And then do we divide by 60? Yes. And we get a constant of 4. So 4 times what's set on the pump, we get 136 mics per minute. All right, happy calculating.